All right, have you ever really stopped to think about how your computer does so many things on the internet at once? I mean, you're browsing the web, you've got music streaming, files are downloading, emails are popping in, all at the exact same time. How on earth does it keep all of that data straight without turning into a jumbled mess? Well, that's exactly what we're going to break down today.
Think about it. When a little packet of data arrives, how does your computer know if it's part of that song you're listening to, or if it's for your web browser, or your email? It's kind of like a postman trying to deliver mail to a huge apartment building, but they only have the street address. How do they know which letter goes to which person? Without a system, it would just be total chaos. Today we're going to uncover that exact system.
And to wrap our heads around all this, we're going to use one simple but really powerful analogy. Your computer is an apartment building. Seriously, this is the key to understanding how your machine manages all that traffic so flawlessly. So, for the next few minutes, I want you to completely forget the idea of your computer as a single house with one front door. Instead, picture it as this giant, sprawling apartment complex. It's got one main street address, sure, but inside, there are thousands and thousands of different apartments, and every single one has its own unique number.
And this is where it all clicks. This analogy maps perfectly to the digital world. The building's main street address, the thing that gets the mail to the right property, that's your computer's IP address. And that specific apartment number, the one that gets the mail to the right person inside the building, that's what we call a port number.
So a port number is, pretty simply, a number between 0 and 65,535. And it acts like a unique digital door for every single application. When data arrives, your computer's operating system just looks at the port number and knows exactly where to send it. Ah, this is for port 43, that goes to the web browser. This one's for port 25, off to the email program it goes. It's literally the internet's internal mail sorting system. But, not all of these digital doors are the same. Just like a real apartment building has public areas like the lobby, private offices, and maybe some temporary guest rooms, the digital world has different kinds of ports for different jobs. They basically fall into three main categories. First, you've got the well-known ports. Think of these as the building's public services, the mailroom, the lobby, things everyone knows and uses for standard universal functions. Then you have registered ports, which are more like reserved office spaces for specific companies or apps, like a particular video game. And finally, there are dynamic ports. These are like temporary guest passes, just assigned on the fly for a single conversation, and then they're freed up again. And believe me, you use these well-known ports constantly without ever realizing it. Anytime you browse a standard website, you're using port 80. See that little lock icon for a secure site? Yep, that's port 443. Sending an email? That's port 25. These numbers are the absolute bedrock of how the internet functions. Okay, so we have the building's address, the IP, and we have the specific apartment number, the port. So what happens when you put them together? You create the complete, perfect mailing address, and in the tech world, that's called a socket. The whole concept is really straightforward. A socket is just the combination of an IP address and a port number, usually written with a colon right in between them. So if the IP address gets data to the right building and the port number gets it to the right apartment, the socket is the complete, totally unambiguous address for one specific end of a digital conversation.
Let's see how this actually works. Every single internet conversation needs two sockets, one on your end and one on the other end. So when you connect to Google, your computer makes a socket using its own IP and a temporary dynamic port. It then reaches out and connects to Google's socket, which uses Google's famous IP and the well-known port for secure web traffic, port 443. That unique pairing of those two sockets is what defines your specific private conversation with Google, keeping it totally separate from everything else you're doing.
Now, understanding all these digital doors is the absolute key to one of the most practical things of all, security. I mean, every apartment building needs a security guard, right? And in the digital world, that guard is called a firewall. So this is the big question, isn't it? If there are over 65,000 potential doors into your computer, how do you make sure that only the right people get through the right doors, and that all the other doors are locked up tight against any intruders? Well, that's exactly where a firewall comes in. You can think of a firewall as a security guard with a really simple rulebook based entirely on port numbers. A network admin can set rules like, hey, allow all traffic trying to come in on port 443 because we want people to visit our secure website. But they can also say, block all traffic trying to get in on port 22 or port 21, because we definitely don't want anyone trying to log in remotely or transfer files. By setting these simple rules, they control exactly which digital doors are open and which are slammed shut.
And this is just so critical for security. Every single open port is another potential way in for an attacker. So by using a firewall to close every single port you don't absolutely need, you dramatically shrink the number of doors an attacker can even try to knock on. You're reducing what's called your attack surface, and that makes your whole system vastly more secure.
Now, I know this all might seem a little abstract, but this is the cool part. You can actually see this entire system working in real time on your own computer right now. Let's take a quick peek under the hood.
So if you're curious, just open up a command line tool. On Windows, that's Command Prompt. On a Mac or Linux, it's called Terminal. And type in this simple command, netstat-an. Press Enter, and you'll get a whole list of all your active connections. You'll see a local address, which is your computer socket, and a foreign address, which is the server it's talking to. Now look through that list, see if you can spot any connections where the address on the other end finishes with .443. Found one? That's your web browser talking to a secure website.
Every single line you see in that list is a completely separate conversation. Your music stream, all your different web pages, your email sync, each one has its own unique pair of sockets, making sure the data from one thing never ever gets mixed up with another. It's a really elegant and amazing system when you see it in action.
So, we've pretty much solved the puzzle for our one single apartment building. But what happens when you have hundreds of these buildings? How do you organize traffic for an entire digital neighborhood? Well, that is a fantastic question and a topic for our next explainer. Thanks for joining me.